Students, today we are going to study about the rules for writing the name of coordination complex. See, the International Union of Pure and Applied Chemistry formulated certain rules to denote the name of the coordination complexes. Let us see one by one. The first rule is, how do we write a name of a simple salt? First, we write the cationic part of a simple salt, following by the anionic part. Same way, the first rule in writing the name of or the formula of a coordination complex is, write the formula of a cation first. The cation may be a simple cation or a complex cation, then followed by writing the anion. The anion also a simple anion or a complex anion. Look at this example given in this module. Sodium hexacyanide. So here sodium is cation. It is a simple cation. Okay. Then hexacyanide is enclosed in the bracket. So it is a complex anion. So while writing the formula of this complex, write the cationic part, that is Na. Sodium is a cation first, following by the anionic part, that is hexacyanide. So let us see the next example. See here, the cationic part is complex cation and the anionic part is also a complex anion. So complex cation and complex anion is found in this given complex. Diamino silver is cation. It is a complex cation. Dicyanide is a complex anion. So first write the cationic part, it is in complex. Okay, it is a complex cation, then following by the complex anion. The second rule for writing the formula of a coordination complexes. Let us take a complex cation first. See, there is a coordination sphere, isn't it? The complex cation, there is a coordination sphere. So how to write the symbol in the coordination sphere? See, the given compound consists of a cationic complex and a simple anion. The name of this complex is pentamine chlorido cobalt sulfate. See, the cationic complex consists of a central metal ion, that is cobalt. First write the cobalt in the coordination sphere, followed by the ligands. There are 5 amine ligands. Okay, so 5 ammonia ligands are there and 1 chloride ligand is there. Must write the name of the ligands as per the alphabetical order. Whether they have charge or not, don't mind. Okay, so how will you read this complex? Pentamine, amine, A comes first in the alphabet. So how many amine? 5 amines. Pentamine chlorido, chloride radical should be written right, chlorido. So pentamine chlorido cobalt sulfate is the name of the compound. But while writing, first write the central metal ion, then while writing the name of the coordination complex, first write the central metal ion, then ligands as per the alphabetical order. The central metal ion is cobalt. First write cobalt. 2 types of ligands are there. There are 5 ammonia molecules and 1 chloride. So the alphabetical order is ammonia first, following by chloride. If polydentate ligands present inside a coordination entity, while writing the name, first must consider the alphabetical order. See, in the given example, a cationic complex is given. Here, 2 chloride radicals. It is a simple anion. It is a monodentate ligand. So En is nothing but ethane 1,2-diamine. It is a polydentate ligand. We can't write this ethane 1,2-diamine as such. This ethane 1,2-diamine as En twice. It's a polydentate ligand. That means this ligand can capable of donating two lone pairs of electrons to the central metal atom. Polydentate ligands are also listed alphabetically. While listing in alphabetical order, the first letter of the abbreviation of the ligand is used to determine their position. Third rule for writing the formula of coordination complexes. The formula for the entire coordination sphere is enclosed in square bracket. In the given example, potassium tetrabromido cuprate. Here, tetrabromido cuprate is anionic complex that should be enclosed in the square bracket. So, we can see there is a square bracket is given to tetrabromido cuprate. Potassium is a counter ion. Tetrabromido cuprate is a complex anion. Okay, that's why it is enclosed in the square bracket. The fourth rule for writing the formula of coordination complex is write the formula of polyatomic ligands and the abbreviation used for the ligands are enclosed in the bracket. For example, ethane 1,2-diamine is a polyatomic ligand and also it is a polydentate ligand. So it should be written like En. Okay, E stands for ethane, N stands for amine, N. Okay, next one is EDTA. What is EDTA? It is also a polyatomic polydentate ligand. See, ethylene, CH2 double bond CH2 is ethylene, you know. Here, in ethylene, there are two amine group, NH2 groups are substituted. Instead of this hydrogen, acetate group is substituted. So, the name of this ligand is ethylene diamine tetraacetate. Okay, it is a polyatomic polydentate ligand. It is abbreviated like EDTA. Okay, next one is pyridine. Pyridine is written like PY. Okay, in the given example, ethylene diamine cobalt 3 chloride is the name of the given complex. So here diamine bis ethane 1,2-diamine cobalt is a cationic complex, whereas Cl minus ion is a anion, symbol anion. The fifth rule for writing the name of the coordination complex or the formula of the coordination complex is help of an example let us study. Here a cationic complex is given in the given example. So how will you name this complex? There are 4 amine. So tetramine, there is one molecule of water, aqua, there is one chloride ion. Okay, chlorido cobalt. So the name of the coordination sphere is tetramine, aqua, chlorido cobalt. Okay, so what does this rule says? Within a coordination sphere, the metal atom as well as the ligands are listed without any space between them. So there are different types of ligands are found in the coordination sphere and a metal ion, but so don't leave any space between these ligands. Okay, the sixth rule for writing the formula of a coordination complex is if you write a cationic complex or an anionic complex without a counter ion, we must denote the charge of the coordination complex as superscript. For example, the first complex is a cationic complex followed by an anion. See, this cationic complex can be written like this: tetramine cobalt 3 chloride. So the charge of this coordination complex is 3 plus. That's why it is written as a superscript. 3 plus is written as a superscript. So in the first complex is a cationic complex. The counter ion is chloride ion. So there are 3 counter ions are there. When you write the cationic complex, the number of counter ion should be denoted as 3 plus as superscript. The second example, potassium hexacyanidochromate. It's an anionic complex. The counter ion is a potassium ion. So there are 3 potassium cations are there. So the anionic complex is written like this: hexacyanidochromate 3 minus.